Welcome to this demo of SoftwareAG DevOps Edition with Microservices and Docker. My name is Fabian Senglier. I'm a solutions architect with SoftwareAG Government Solutions. And today I will walk you through the DevOps platform that SoftwareAG provide to build microservices following a CI/CD pipeline and even deploy those onto Docker platforms like Docker Swarm or Kubernetes. And so the idea here of this demo will be to really go from start to finish, build a service, a microservice, and then plug that into CI/CD pipelines, run some automated tests, and then create Docker image for it and deploy it onto a Docker platform. So essentially, we will go through all these stages here, as I explained earlier in the first part of this presentation. And so we will look at how the designer workstations work and how it interacts with a version control system like Git. And then we will go over how to create the code, create some tests, really do the development work like you would as a developer. And then we'll plug that into Jenkins to do automated builds and automated testing. Jenkins in turns will create those, basically these build pipelines where it will first build the solution, then test it, and then the last step will be to store it into a Docker registry, right? And then from there, once we have our new microservice stored as a Docker image in the registry, then it's very easy using Docker scripts and Docker commands to run that microservice into your environment of choice. Here I will show you that I have a Docker Swarm environment and we'll be running our microservice in that environment as a last step. And then we'll run a couple of queries to it to make sure it works. And so that will end our flow and our demonstration, right? In terms of the microservice we'll build something simple, to keep the complexity down from a coding standpoint. But all the concepts will still apply at each stage for any other types of solution. So let's first look at the environment as a whole, right? And kind of understand the various pieces. Here we talked about that in this sort of diagram. But first I will show you our development environment. So our development environment is essentially our designer workstation, which for those of you familiar with Eclipse, you'll be very familiar with this UI. It is based on the Eclipse platform for more traditional Java, development. And then what SoftwareAG does and webMethod is add new perspective and new plugins onto that Eclipse platform to make the development easy, and build what we all love about webMethod, which is build code with drag and drop and flow, and really make it easy to create services, REST services, SOAP services, and using all the wide library of adapters to make it really easy to connect to various systems like databases or other third-party products you may have in your organization, right? So, so designer is definitely the central piece of the developer, right? For the development of your solutions, and then on my local environment, I will also have a microservice container or webMethod integration server process running where I can kind of test my package, right, and see if it works as intended, right? So so that's the local portion of the development, right? So as a developer here, I'm pretty self-sufficient and I don't need anything else. I have it all on my local and I'm ready to start. The second piece that I want to show you is the Git repository. So I have created a Git repository, very similar to GitHub here, but it's an internal repository, private, right, for your organization and for this demo as well. So here that's where you will have your code centralized, and have all the developers, basically commit their changes, their update, their new features to those repository, right? So I have a couple of repositories that I created. This one we will go over. It's the Fibonacci. That's the microservice we're going to build throughout this demo, but obviously, the other, every developer could have many, different repositories, and that's just how it works in terms of code management, right? So we will have that, and we'll use this to store our code, right? Our microservice, Fibonacci microservice, right? The next step is we'll have Jenkins, right? So Jenkins is the automated build product that is able to do a lot of things. There are a lot of plugins available to connect to various systems, including Docker and Git and various code source repository. So it's really full features. It's something very well known in obviously the development and automated testing industry. So here we're just going to use that very well known tool to basically get the code from our code repository that I just showed you earlier, right? It will just check it out and then stage it in its build workspace, and then start to build it, run some tests on it, and then possibly store that to Docker or any other systems, right? And that's all defined by a Jenkins file. We'll go over this, right? But that's your Jenkins environment here, right? And then at the end of the day, what we really want is to deploy that microservice onto the target environment. And here my target environment is a Docker swarm, right? So in this Docker swarm, that's where you are able to deploy various microservices as you see fit, right? Here, as you can see, there are definitely different microservices already deployed, but the idea is that this Fibonacci service here at the end of the day will be deployed onto that Docker swarm, right? And may or may not interact with any other service as well, right? And I'll show you some of that, towards the end of this presentation. The idea, obviously, about the Docker swarm is that it's a very easy way to scale the services. It has all the underlying, commands and APIs to simply say, hey, I want my Fibonacci service, microservice, right, to actually be scaled to 4 instances instead of 2, right? And Docker Swarm, on its own will decide where the Fibonacci service can be put based on resources or based on rules you would have set. But the idea is that you can really scale up and down within this architecture, right? And obviously, Docker Swarm is not the only orchestration tool. The same could work very well with Kubernetes, as well as some of the platform as a service like OpenShift or Cloud Foundry. Here we just decided to use Docker Swarm in this demo. Okay, and then the last piece of the puzzle is the Docker registry, right? So when Jenkins is done with the build, the first thing it's going to need to do is going to need to store the actual microservice image. It's going to create a Docker image and need to store that into a central registry so that we can all access it ongoingly down the road, right? Like to either deploy it onto that swarm that I just mentioned, or maybe use it as a developer too, right? Like in terms of, another developer may want to test the newest microservice built on his laptop, right? And using the power of Docker, you're able to simply download the image and then just run it on your laptop without any issue, right? And you are able to easily see the end results of that build and and maybe the new features you wanted to test, right? Or you wanted to use for another microservice that you wanted to connect to it, right? So a lot of options, but long story short, very easy to do that with the Docker technology, and especially once everything is in Docker registry, then it's a simple, quick download away to run any service that you may want, right? So that's a very important component, and we'll be definitely leveraging that into our pipeline and our demo, right? So those are all the pieces that I wanted to quickly talk about. But let's go back to the development aspect, right? So now I'm the developer, and I have this new microservice to build, right? And I have already built that Fibonacci, but that Fibonacci service, and we'll look at that in a little bit. But first, let's look at how we can even create a new package, right? And how it works to create a local service development package that we connect to Git, right? So let me show you that in a very few steps. But first, as I explained to you earlier, SoftwareAG provides various perspective in Eclipse to build whatever you need, right? So here we're just going to build a microservice that will expose the REST interface. And so we're going to use the flow service development UI or perspective, right? If you wanted to build business process flows, maybe that you would pick the process development, right? Rules development, right? So as you can see, it has different perspective based on what you want to build. And in addition to the general perspectives of that you're probably already used to it if you use Eclipse, but that the Git perspective, the Java perspective, etc., right? So here, just so that we're all on the same page, I'm building a microservice, so I'm going to go to the service development, okay? And then here, what we see is what is currently available to me on that local IS that is running, right? Oops, too many windows. Okay, that local IS that is running here, where I'm going to be able to test my code, right? So, integration server comes with a couple of packages that will help you do things as you need, right? Some adapters or some public libraries to do things like string manipulation or math or some pre-built algorithms that you may need, right? So those are the built-in package, and obviously you can add more or remove some package if you don't need them, or add more if you need more, right? In terms of maybe connecting to a Hadoop backend or to a database of some sort using JDBC, right? As you can see, the actual JDBC adapter is right there. But long story short, that's what you see here, right? And so when you create a new package, right, it's going to create that package onto the local web method, and you're going to be able to test instantly what you're doing, right? So it's pretty nice that way. So let's do a test 4. And this is going to really just show you how to do it quickly, right? And then we'll switch back to the actual service with that is built into my Jenkins pipeline and all this. But long story short here, so you can basically create your package, right? And then like we demonstrated or explained in the presentation earlier, the idea is that we want to be able to connect that code that I'm about to do, right? I want to be able to push that into Git from my local development, right? So, so the best way to do this is to transform that package right away as a local service development project, right? And so as you can see on the right side, on the the pop-up here, we have a couple of choices, but the one that I'm mentioning is the create local service development project. And so what it's going to do is it's going to still obviously keep the package available to us in webMethod to be able to ongoingly test, but it's going to also connect it to a Git repository. And so that's what we are going to quickly do here. We are going to put the Git repository directly into the package location for simplicity's sake here, right? And then we need to just create a repository, right? And then we do finish. Okay, and as you can see, all of a sudden we have basically this new icon that is basically added, which means that this package, while you still can test it obviously like you would normally, and just will add a couple of like a quick flow service in there, but it also means that it's currently ready to be pushed into Git. And the other thing also that you want to do is to connect your current package right here, to connect that to your central repository, because now it is connected to a local repository, but you definitely want to push your code to that central Git repository that is backed up, and that also is the central repository for your whole team of developers, right? So your code definitely needs to be pushed there. You don't want to keep that locally, right? So the way to do this in Git is to add a remote, and so the UI here, the Eclipse UI for Git shows you the repository that currently the package is using, and currently it's local. There is no remote, right? You could start building code, and the local repository is going to start tracking the versioning. But again, that is not the exact way to do things, because you definitely would want to connect that to a remote. So the remote here is our central Git server, and so we're going to do that. We're going to quickly create a new solution, a new repository onto the remote. So let's do this quickly here. We're going to create a central repository called test4, which is the one that I'm currently creating. Then you recognize some of that screens here if you're a GitHub user already. A license, a README, and then you can say, okay, create repository with those files. Okay, so now we have our central repository here that is empty, right? Minus a couple of files here that were automatically added. Long story short, what you want to do is you want to connect your local projects right now to to that repository. So I'm going to copy paste that URL, and we will add a remote here into my Git project here locally. So I'm going to create a remote. I can name it origin, which is the usual traditional name for the remote, at least the first one you add. Then you will put that URL here, copy paste. Okay, so that's my host name of the current Git server. I want to use SSH, right? The URL is fine. I'm using a different port for SSH, so I need to make sure I'm putting the right port. And then what's going to happen is I have a private key that will allow me to connect to my SSH repository, so I don't need to put a password here. When I try to connect, it will use my private key that I have already registered with Git. So I will click finish, and here I can do save and fetch. And as you can see, it is automatically trying to connect to the repository and fetching what's in there, right? And so currently there is only one branch on the remote, which is master. Perfect. And so I'm going to fetch this. Okay. And so now I'm connected to my remote for push and pull. And then the last piece of effort you need to do here in terms of Git, and that's all Git flow really. Not much to do with webMethod, but just making sure you connect your solution to Git properly, your package, right? Then currently you don't have any branch locally, right? The master branch is remote, and so generally you definitely want to check out the master branch also locally. So that's what we're going to quickly do. We're going to switch to new branch, and then we're going to say, or actually another way, we're going to just like check out here the remote branch, and we're going to say, okay, create checkout as new local branch, right? It's actually easier. That way it pre-fills everything. And now I have my local branch here, perfect. I'm connected to my repository, so now I'm really ready to go to add things as needed. So it's great. So I'm going to now, let's say, just add a folder, wx test4, great. And then here I can just say, okay, add a flow service. Okay, where is my flow service here? Okay, here, sorry. My new service. Okay, and then my new service is going to be created like I mean you if you're already a web method user, you know that it's very easy to create code using drag and drop, right? Some like branching, some looping, like maps is to assign, you can assign variables or create transformations here, right? So we could quickly do new var, right? And then just assign some text to it. Hello, my first service. And now we could essentially test the service. We can easily run it on the local integration server that is currently running. That service is actually hosted there currently. And then we can say run flow service. It doesn't have any input right now, but as you can see, we see the output. The service has run properly, and is showing us our new variable that we just added as an output, right? So that being so, obviously this is very simple, but this is not what we are concentrating on now. We are just showing you that now we will want to commit that code, that new code to Git, and try to follow the pipeline, right, of testing and of automatic building and all this. So now what we want to do is commit that new code to the repository, right? And so the Eclipse Git plugin provides a visual ways to do that. And here this is in the Git staging view. But here you can essentially see all the files that have been changed since I created my service and my folders. So what we want is we want to make them to stage them for commit, right? And then we're going to say, okay, my new code, and then we're going to say commit and push. So we are going to commit as a new version, add it to the repository, and push to the remote, right? That's what this commit and push does. And so great. So now what it says is that the code is in that central repository and it's been pushed properly, right? So we're going to close this. We can basically check here that it's been added properly, and yes, we have our folders, basically representing the code of our new service that we just added, and the flow code here as well. And from a UI standpoint, you can also see that now it shows as not changed, right? So and so that kind of closed the loop on just like now you're ready to go to add more complex things in your service, and you're connected to a central Git, and all your other developers can just do the same. So that's the first stage. The second stage is to create tests, right? And so here I'm going to go back to my Fibonacci service just because it's a little bit more interesting. It's actually doing something, which is the Fibonacci series. So it's doing some calculations, essentially like the Fibonacci algorithms is created using simple flow, right? And so the idea about that service is to provide basically a number, flow service, a number in the series, and then it's going to calculate what's the value, right? And so we're going to run this number 50, and then Fibonacci number for the 50th number in that series is that value, right? So this service is created, and here you can also see that I've created a REST endpoint for the service, so that I can actually call it from, as an API, right? And that's what you would traditionally want to do in the microservice world, and then possibly register that API onto an API gateway, probably the topic of another demo at some point in the future. But so this Fibonacci service, now I've created some code, right? And I want to create some unit tests to make sure that this code is behaving properly, right? And make sure that there is no regression, make sure that when I commit something to the repository, I have a couple of tests that really guarantee the stability of that code, right? So that's where unit tests come into play, right? And so the local development also come with a unit test perspective. Here, that's where you are going to create your unit test project, and where you are going to create those unit tests for your solution, right? So following the sort of very visual approach to coding, the unit tests also can be created very simply from basically UI, all right? And so here you would, we recommend to follow that specific structure where the inputs and expected outputs are stored in a data folder, and the actual tests and test suites are in the setup folder, right? For sort of readability, right? But that's not, mandatory structure. It's just like what I like to do in terms of setting up a project. And so in that setup folder, we are going to create our test suites, right? And so here I created already one. We could add a new one by right-clicking, new test suite, right? And then it would create that very test suite here, right? And so the idea here is that we can simply add new tests to it. I've created already 2 tests here. We could add some new ones by simply just doing insert. And then here we could say, okay, my new test, right? Some description. And then here you go, right? You have your new test. And in that new test, what you want is to basically specify like the service that you're going to want to create to test, right? And that's going to be our get next number service. And then in that service to be tested, we need to simply define the inputs and the outputs that we expect, right? And so that's where what's in the data folder is going to come into play to provide some inputs and outputs, right? And so in our success case, what we are going to do is we are going to provide a certain input, which essentially is a web method pipeline piece of XML, defining the valid input, right? And so the valid input here is essentially, the number 50 that we tested earlier, right? And then the expected output is this number, right? Now you may wonder, well, how did you get that snippet, right, of XML, right? And so that's actually very simple. Let me save this. It's actually, you can get it by executing the service, right? So go back to your flow, right? Then we're going to simply do run as service. And then here you can actually save that input 50 plus the argument. You can save that as an XML, right? And so here you're going to say, okay, my input .xml. Okay, and then when you run it, you can also save the output of the pipeline, right? And so this actual number here, we are going to save pipeline locally, and same thing, like my expected output .xml, right? And now going back to my test, I have my new input and output here. As you can see, that's exactly the piece of code here that I needed, input and output. And that now I could use into my actual test here to put the input and expect the output. And I could even do some parsing and with the output. So long story short, here we have a way. I'm going to delete those extra files that I created here. But we have a very easy way to test our service for validity, right? And then quickly talking about the other service, which is the exception service. Here, what we are simply doing is we are passing a invalid input, right? So let's see, invalid input is -1 in the Fibonacci series. And so that should return some sort of error as planned by our code. And so we want to make sure that it's still the case. If another developer somehow had made a change that made -1 a valid value, our test case here would notice it, and it would break the build, right? So basically here what we want to do is clean up all those tabs and simply run the test. So we are going to run that. And because it's a WM test suite, automatically we see that we have the web method test suite popping up here. And so simply, basically our two tests are successful. In the console, we see that, you know, for the exception case, it returned the right value, the right exception, sorry, saying, you know, hey, you cannot put -1. But long story short, the important screen here is the JUnit screen where it shows us that both tests have passed properly. And so if I was going back to my flow here and I don't know, I'm the other developer and I just did something, I think like this step is not needed. So I'm just disabling this, you know, but, you know, as the other developer, because we have our unit tests here, we could easily check that everything is expected, right? So I'm going to rerun it, web method test suite, right? And then with that change, well, the success case is just not working. The value that we get is not the expected one. Something is wrong in that code, right? And so that's a very easy way to make us aware as a developer that there may be a mistake. But obviously, some of the mistakes that you create, you don't necessarily realize those. And that's the goal of those tests, to automatically test your solution as you build it. And so that's exactly what Jenkins is going to do when we run the pipeline. It's going to run those tests. And such a build right now would be failed on the Jenkins pipeline build, right? And so that, I think, is our cue to go towards the Jenkins now. Now we've covered how to create a flow, how to connect it to Git, how to create some tests, simple tests here. And so now we will just quickly show the Jenkins and the pipeline aspect. So let's open Jenkins now. And so in Jenkins, like I said, it can basically run all sorts of builds for all sorts of solutions. Here we are going to run builds for the web method project that we just created. So I already created a Fibonacci, basically job here. And so let me log in again. Okay. So I created this Fibonacci. As you can see, I already run some tests here of actual pipeline. I will explain a little bit what those are, but quickly in terms of configuring the pipeline, there is nothing too specifics for it. Long story short, what you really want to do is you want to create that job, and then you want to say, okay, where the code is, right? So it's in Git. This is the URL for my projects that I want to run here, your credentials to connect to it, right? Couple of other options you can choose to use or not. Here I did because I had some sub modules in Git that I wanted to fetch. So Jenkins provide this very nicely as options. And also what you want to say is to provide the name of the Jenkins file that will contain the various stages that need to be run by Jenkins, right? One thing that I didn't mention is that Jenkins has two ways to do things. You can either say, hey, the actual Jenkins file is in my repository alongside the code, which I think is a good practice, so that you really have you really leave to the developer the responsibility to build a proper Jenkins file for their solution, and really Jenkins at the end of the day is just the runner of whatever steps were defined. So that's one way of doing it, but the other way would be to actually create the pipeline scripts centrally in Jenkins. So that's the other way. I chose to use the one where the Jenkins file is in Git alongside my code. And so that's where you want to say, hey, this is a Jenkins file that you will need to look at, right? So once you do this, here, I guess I could save. So before I can run, or I guess I could run now, right? Then once you have that set up and the Jenkins file is in the proper folder in your solution, which we are going to look at this right now in my Fibonacci, right? Here, as you can see, the Fibonacci project that I created has a specific structure. Basically the package is grouped into an asset folder and then IS for integration server, and then that's where my packages are, and that's where the Fibonacci project is. The idea is that a single project could have multiple package. It's definitely a common scenario. So that's where you could put all your other package related to Fibonacci, for example. And in addition, you also want to put your tests in the same sort of structure to kind of centralize everything around that project and that you're kind of building, the Fibonacci project, right? So all my tests, like we saw in Eclipse, they end up being in that sort of structure, right? Where you get the setup folder and you get the data folder that contains all the XML files, right? So a very kind of easy structure to drill down to. And by the way, the assets for your solutions could be, integration server, but it could also be some MWS assets. Maybe you created some CAF UI page, right, to display some things, right? Or maybe BPM, right? Rules or flows also as well in your solution, right? So that structure also provides for ability to add new types of assets in your project. So definitely it is a recommended structure. And by the way, since I'm at it, there is the SoftwareAG GitHub project that has a sample project layout which follows that very structure that I just explained, and also provides some start Jenkins files and other things, and build file for Ant building, right? So this is definitely a good project to look at, the sample project layout, and that's the one that I definitely used just because it makes sense, and it's very easy to leverage the existing scripts already. So back to my actual solutions and back to the Jenkins file, right? So this is where we are going to quickly explain. Obviously, we don't have time here to explain all the intricacies of how to build a Jenkins pipeline, but in that Jenkins file, we are going to do a couple of things. Jenkins file structure is as follows. Where you define a pipeline, and then you define the agent you want to use, maybe some environment variable that you want to define, options for your builds, do you allow concurrent builds or not, things like that. So that's like internal options. But the most important part is the stages. And so the stages section, that's where you're going to define the actual work that you want to do in stages. What do you want to do? You want to first prepare the project, and in my prepare project here, that's where I'm going to start a target test server, right? Which will be basically a microservice container server where I will deploy the code and run some tests against it. So for the prepare stage, I want to start that node. And by the way, here, that's where the power of Docker comes in play. Because when I say start my test server, I'm really spinning up a Docker container for that test server onto the Jenkins server, right? It may be a little wild at first, but basically Jenkins is able to spin up Docker containers. And that's exactly what I'm doing here, right? It's basically doing that. And so at the end of that stage, I should have a running microservice container server, a blank one, nothing on it yet, right? But enough to run my package. Then the next stage is the build stage. So that's where I'm going to build my project. And so this is going to leverage Ant, which is basically a standard build file for, to build Java solutions. And here we're going to use it to same thing, to build our microservice solution. And so it's going to use that Ant file and also spin up a build server using Docker that contains the necessary libraries to build a web method flow project. And those libraries, they are the asset builder environment libraries, right? So in that builder image that is automatically spinning up, it will have all the necessary artifacts to build my project. And so all I need to do here is run the build against this. And then the deploy. So that's going to leverage another Docker image that contains deployer, web method deployer. And what it's going to do is going to take the artifacts that were built in the previous stage and deploy them onto my test server that was, prepared at the beginning, right? So now at the end of that deploy stage, I should have my Fibonacci package ready on that test server, right? And deployed and should be running and should be available. And the last stage is the testing stage. So now I have my test server that contains my Fibonacci code, and I want to test it. I want to run those unit tests that I created. And so that's where I'm going to spin up a WM test suite image or container, right? Where I'm going to say, hey, run those XML tests automatically, right? And then the output of that test phase is a report showing you basically if the build has failed or passed. And so if all goes well, and the stages, right, they run sequentially, right? So you do the stage first, prepare, then after build, then deploy, then test. And if all goes well, then the last stage will be to save that newly built and tested artifact into a Docker registry, right? And so that's the stage that I call save to Docker, and that's where I'm going to say, okay, well, my build is good. It's passed the test. It's passed the build stage. So now let's create an actual Docker image for it and push it into the registry, right? So that's what those lines are for. Okay, and the beauty of Docker is that at the end of all this, you can simply say, okay, destroy everything you've used here because we don't need it anymore, right? Everything is not needed after this build, so you can simply put it all down and remove all the artifacts. And because now the actual build artifact has been pushed to the registry, is versioned, and so you don't need anything else anymore, right? And so you end up with that cleanup stage here, which is always run at the end. So this is obviously, a little bit more, requires definitely digging up under the hood to understand more about this. But at the end of the day, this Jenkins file is very simple to execute on Jenkins, and we'll see if that actually ran properly here. And it did. Oh no, I didn't. Did I start? I may not have. So this Jenkins file is the one that is going to be read by Jenkins right now when I start a build. So I'm starting a build right now, and as you can see, you see the stages: prepare, build, deploy, test, save to Docker, right? And so the idea is that it's going through the stages, and like I explained, the prepare here, it spins up a server, the build, it spins up another server with ABE, the asset builder environment libraries in it, and then run the Ant script against it. The deployer here is spinning up a web method deployer and pushing the build artifact onto the server that I spinned up initially, right? So it takes a little time to do that. And so you let it run, and we'll basically reconvene at the end. Okay, so the build or the pipeline ended successfully here. It took 1 minute 36 seconds to run, and as we can see, all stage passed. And so so now our build 44 is a valid build. And so what happens, right? This build 44 has been saved to Docker, and that's the interesting piece here, right? Is that now we have this new piece of code available, and that should be available in our registry. So let's check it out. So this is our Docker registry. I've created a quick front end for it. And then I can see what's in the registry. And so I'm going to go check my Fibonacci. And so as you can see, I've built definitely already a bunch of different iteration of that service. And that would be perfectly realistic. And so let's do a quick refresh of that page. And then look for our build 44, which is 2 minutes ago was created. And now basically I have this Docker image here tagged properly. It's a 10.1 web method 10.1 and then build 44, right, for Fibonacci. Right? So very nice. Now I'm able to possibly do a Docker pull from the registry to get this and possibly run it either on my local, which we could try, or basically on the swarm, which I think will be a little bit more interesting. One interesting thing too is that each time I'm building a new version that is properly built and valid, I'm updating the latest tag to be that latest version, right? So now as a user of that Docker image, you have the choice to say, hey, I want the latest, or you have the choice to say, hey, I actually want to go back in time and check the build 21 days ago. What did we do with that one, and what are the differences in behavior, right? So you definitely have this very kind of nice history of all the builds that you've done so far. So, but before I run, I wanted to quickly show a failed build, just so that we close the loop on those tests that I've created, right? So let's now go back to the development, and I'm a developer, and like I showed a little earlier, I just thought this subtract int in my Fibonacci algorithm was just not needed, so I just disabled it, right? We know that the build is going to fail. We run some tests locally, but let's say it's something I really didn't realize, and I'm going to check in that code, right? So let's go to Git staging. Here I'm going to check the relevant changes related to my change here, which is really disabling a section, right? So here I'm going to say, hey, new improvement, right? I'm not aware that I'm breaking something, and I can't type. New improvement. And then commit and push. Okay, so as a developer, I think all is well. I just push my code, I'm really happy, and basically my new improvement has been pushed into the repository, right? So from there, we have basically schedule build running, and maybe a manual, and by the way, this Jenkins can run it every time you check in something, can do it nightly, various capabilities in terms of what it can do. But here we just do a quick manual build, and then we'll see if it fails at some point or another. And the expectations here, since I know the tests are going to fail, is that it should fail at the test stage. And since it's going to take a little while, we'll reconvene at the end of this build. Okay, so we are back at the end of this build, and we can see that it is yellow, meaning that it's an unstable build, meaning that they found something not quite right with it. If the line was red, it means the actual build would have failed, the actual building the binaries, right? But here the build has been okay. It's just that some tests were not right. And so let's look at build 45 here, right? And as you can see, there is one failure in the test, right? And that's the success case. And we can see that basically the Fibonacci number, what we expect versus what we got, is just not right. And so that's a very nice way to say, hey, you know, there is a regression, something happened, right? It doesn't quite tell us the line of code that changed, but really it gives us a good assessment where to look, right? And in that particular case, obviously we know what we did, but otherwise, you know, it would basically tell us that something is wrong with that particular service and that particular test, right? So, so this is definitely showing how to run, how like Jenkins can identify regressions and identify issues during build time, which is exactly what you want to do, right? In an automated process. So before I move forward, I will just fix my code. That way, you know, I just don't have a failed build again. So I fix my code, and then I don't forget to basically commit that, fixing my code. And then that way, everybody else can start working again and having builds that, you know, basically that succeed. So let's do this, close. We can check in my Git that my last commit really reached the central repository, shows fixing my code, that's the last commit, perfect. You know, essentially you probably as a developer would want to go to your unit test, make sure that the test now is working fine. You know, before you actually commit, that would probably be a good idea. And here, you know, okay, everything is running fine, right? And so if I'm starting a new build now, build 46, I guess, so going back to the build window, you know, I could start another build and, you know, I'm pretty confident it's going to be okay now, but, you know, we can just do it and see. But while we run this, what I wanted to show is build 44, right? Like I said, it created a build that was working before I made that mistake, right? And that build generated a Docker image. And so to close the loop, I just wanted to quickly deploy that image onto a Docker swarm or even run that locally. Because like I said, the registry is available to your organization, right? And, you know, obviously, provided you have the right access and, you know, authentications and things like that. So let's first try to run that build locally just for fun to show that we can run a Docker image on our local or any other developer platform very easily using a simple command. And then in the second stage, we'll just deploy that really to the swarm, which is really the target environment where we will be testing our, you know, our service. So let's look at the URL for that Docker image. It's there, so we copy paste that, and then I go to my local. I make sure nothing else is running right now, and then I will simply just do a Docker run, map the port for IS from the Docker environment to my local environment. That's just the way to do it in Docker, and then provide that URL. Here I just need to add the full domain name, and I think we're good here. So I will run this, and as you could see, try to explain what we see, but the 44 build image was not on my local yet, so it's been pulled from the registry, and interestingly, right, in the stack, you can see that a lot of the layers for Docker already existed on my local. It's one of the great things about Docker is the fact that you know, if you have some layers like a base OS or maybe the base web method container already on your local, Docker is pretty smart at only pulling the layer that has changed and that you need, right? And in that particular case, we just needed the layer for the service. for the actual code we created, right? All the rest is very standard microservice stuff or very standard Linux OS, etc. Right? So very nice, right? That it only pulled probably a couple of kilobytes here, as opposed to pulling again, a full image with the OS and all that. And while I'm talking, it should have started. So IS has already started here, and so let's quickly check that our local host 555 is available. And so I'm gonna log in. So I'm on my local right now, really exploring that Docker container that I just started for Fibonacci. And so let's check if the Fibonacci package is here. Yes, it's here, as we would expect. And then we can quickly check the service, right? Hey, get next number. Let's test the service, 25, test with input. Okay, that's my number, right? We could also test that with the REST endpoint that I as well created earlier. And we'll do that with the Swarm anyway. But this is all working and running. While it shuts down, I will show you the Swarm aspect, right? So on the Swarm, currently we don't have our Fibonacci server running. And so let's have it run, right? And let's see how that goes. And so I will log into my manager, Docker Swarm manager, and then I'm simply going to run a command that I have saved here, which is docker stack deploy, and then the name of that file for Fibonacci. And then the name of my stack, Docker stack, right? Okay, so now the service is actually being created, and look at this, how fast it is. It basically, essentially is pulling the container from the Docker registry, and then just running it onto two of the workers as it sees fit. And you could see that it would pick those because those are the less used at this point, were the less used. So basically the Fibonacci service was, started on those servers. So now what you could simply check is, okay, so now the service is running. We can check Fibonacci is running 2 of those. And it's running the latest, right? Which is really my latest build. So it's great, right? Quick things that you may want to try is, use the Swarm capability to scale out this service. So Docker Swarm, Docker service scale name of service equal 4, for example. And as you can see here, it's pulling 2 more and putting them where it needs to put them, but basically to meet the new comment the new request that you're saying, you want 4 of those, right? Not 2, right? And so it's trying to meet that, and we'll put those wherever it can. Here it's, basically we'll wait a little bit, but it's simply pulling them down from the registry, and we'll start them. So it's a process that takes a few seconds. But at the end, as you can see, it's very, very easy to scale up and down your service. And so that's the power of running a pipeline with Docker at the end. And obviously here I'm running manual commands to deploy onto the Swarm, but all this could most certainly be scripted or even run from Jenkins, really. That's something to keep in mind. So now this service is basically running fine, 4 instances, and then you have your Fibonacci, right, in various places. And then I think to finally close the loop, I think what we can check is, we can make a service call, REST service to my Fibonacci Docker, URL, which basically this is really going against the swarm and saying, you know, hey, run that service, run that REST API that we created, right? And so we can just do a, you know, 34, next number 34, and we're gonna send this, and then that's the number, right? And then 50, which is the one we always test, that's the number, right? So your API is actually currently working really well, and it is running currently out of that Docker swarm with the latest update that you just did. You know, and so here you go, you get the full loop of from start to finish, developer creating code, Jenkins building, testing, pushing to Docker, and then finally the service being available onto your Docker swarm, where maybe your testers, like me right now, testing the service themselves, making sure it works, making sure it fits into the rest of the environment. So here you go. I think this is a lot of things that I showed. Obviously, you know, everything takes time to learn in terms of Docker, in terms of Jenkins, in terms of, but really at the end of the day, this demo is to demonstrate that the web method platform fits really well within the standard DevOps infrastructure that you may already have in place for other types of projects. And so you're really able to do all those all this CI/CD pipeline in a very efficient way using all the latest technologies like I showed you, whether it's Docker, whether it's Jenkins, whether it's Git, and do it all within the web method infrastructure. Hope you liked it, and feel free to reach out to me for any questions. Thanks for your attention.